Have you ever wondered how data is kept secure? With the rise of technology, cybersecurity has become increasingly important. In this video, we will explore DES encryption and decryption with Python, a powerful tool for securing your data. Now try to understand the steps involved in implementing DES encryption, like the key generation, image conversion to binary format, and the encryption of binary data using DES algorithm, and the conversion of encrypted binary data to image format. Let's take an example. In first, if we have an image, first we generate a 24-byte key for DES, and then we convert the image to binary format using appropriate software, and then we encrypt the binary data using DES algorithm, and then we convert the encrypted binary data back to image format using appropriate software. DES can be used to secure sensitive data such as financial information, personal information, or business secrets. And the encryption of images is important because it ensures the privacy and confidentiality of the information contained within the image. And the DES provides a high level of security and offers benefits such as improved key strength, greater resistance to brute force attacks, and the flexibility in key management. Here you can see we import DS3, which is a triple DS, and MD5, which is a cryptographic hash function that take input data and produces a fixed size output hash value, typically used for verifying the integrity of data or creating digital signatures, and it generates a 128-bit hash value as output. And OS is stand for operating system, which will be used for input the file path and reading the reading the image from the file path. And let's break down the code step by step. First we prompt the user to select whether they want to encrypt or decrypt a file. Then we ask for the file path and three keys for DES algorithm. Next we hash and adjust the parity of each key. Then we create a new instance of the DES3 algorithm with the first key of mod EX for confidentiality and authentication. After that we read the file from the given path and perform the encryption or decryption operation depending on the user's choice. Finally, we write updated values to new to a new file and display the decrypted image if the operation was successful. And now we run this code. So it asked for encryption or decryption. Let's say we want to encrypt our image. So we will choose one. Now it asking for the file path. So we have an image and we copy the path. So paste the file path here and delete the inverted commas. And now it's asking for the first key. So let I write 1, and second key is 2, and third key is 3. So here you can see the our image is successfully encrypted, and this is the file path where our image is gone. So here you can see it is our original image and it encrypted into this image. So if we want to open it, then you can see it says that new encrypted image and the file format is not supported. So now let's say we want to decrypt this image. So here is the file path, so no need to copy from the, or you can copy from the location from where it goes. So it is already written here that it goes here. So we again run our code and we choose the decryption. Now it's asking for the file path. We paste it here. And now we have, remember one thing guys, like the same key you have to provide it for the decryption. Like we provided one, so we will use one, and second key is our 2 is 2, and third key is 3. So you can see our file is successfully decrypted, and you can see here is our image is decrypted and it shows because it's successfully decrypted, so it automatically pop up. So let's, and remember one thing, no algorithm is perfect and triple DES has its own set of limitations. Like in large systems, the key management can be challenging, and in comparison to other encryption methods, the triple DES can be slower, and the key length is limited to the 168 bits. And if the key length is not sufficient, there may be chance of brute force attacks. But these attacks can be addressed by proper key management practices, optimizing the implementation of triple DES, using alternative encryption methods for real-time application, and increasing the key length by using advanced encryption methods. It has many benefits such as providing strong encryption and being widely used in many industries. Triple DES encryption and decryption with Python is a powerful tool for securing your data. I encourage you to try out this algorithm for yourself and see how it can benefit you.